Hello everyone, my name is Timothy Lee Grant, and something extremely important in Leetcode is to revisit those problems that you initially failed and try to make sure that you revisit them and learn them, because if you just try a problem, fail at it, and then never touch it again, there's not really much help in that. So today we are going to be doing this problem that I failed about a week ago. I haven't looked at it since. I do remember that there was something with union find, and I looked up what union find was, but I can't remember how to implement union find, and I don't remember how this problem works with union find, or if it actually was this problem, because I failed at a lot of problems. So we're gonna see what's going on with this problem, how we might be able to go about solving it, try to remember like what was our sticking point on this. So did I float myself? No, I did not. So I need to fix that problem. Float on top, there we go, and I can minimize myself. Okay, so let's start by reading the problem statement. So 687, longest univalue path. All right, given a root of a binary tree, return the length of the longest path, where each node in the path has the same value. I don't think that this was the union find one. Okay, so again, this is kind of off the cuff. Everything is just me documenting my process of trying to go through Leetcode, trying to understand things, trying to improve at it, revisiting those problems that I failed at initially, trying to, I guess kind of my idea is I fail at it, I see a problem for the first time, I fail at it, or pass. If I pass, great, but if I fail at it, okay, I try to learn and get it where, okay, I think I got it, and then I don't touch it for about a week. I forget about it, and then I go and try to revisit it and try to either get it, or if I fail, okay, well then that might indicate that I need to that there's a deeper problem or something. Because the trick should still maybe be in the back of my head, possibly, and I just need to pull it out. But if that trick is not coming to the front of my head, there might be a problem. But anyways, so hopefully that trick comes to the front of my head, because that would be bad if it wasn't. But anyways, I'll post the video anyways, because I post all my videos, even the failures. Okay, so what? The length of the path between two nodes is represented by the number of edges between them. Okay, so there's a 5 here, a 5 here, and a 5 here. Okay, and what I want to do is, this is not the union find, by the way. I remember that this is not union find. So what I want to do is I want to find the longest path of them like connected. So you can have like here, this is 5, 5, and 5. They're all the same node type. And so I can count this connection and this connection, so there's two, right? So that's the output. There's two because that's the longest number of edges. Okay, and then here we see that it doesn't have to be just like from top node down, down, down. It can be like in this order where it is part of the children and part of the children. So it's like disconnected, or not disconnected, but it's still connected, but it's not starting here, go down, and go down. Now, if there were a node here and a node here, like 4 and 4, we could do 4, 4, 4, 4, 4. So you can connect them like in a snaking pattern. But if it was 4, 4, 4, 4, 4, I wouldn't be able to go like here, 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 here. That wouldn't make sense. It would have to be here, 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 here. Okay, so all right. Now I guess the first thing that I'm going to do is I know that I need a traverse function. So def traverse. Okay, and it's going to be node. Now, what is a base case? Base case is going to be when I when I don't have a node. So if not node, I just want to return. Otherwise, what is going to happen? I remember last time I was trying to solve this problem, I was kind of trying to figure out what information needs to be passed up and what information needs to be passed down. I can't remember if that was the right track. Okay. So possibly what I can do is if I am here, I check what the longest length below me is on the right hand side and the longest one below me on the left. So I check the longest here, and if so current longest equals 0, and then non-local current longest. Okay. So now should I traverse the left hand side? So left equals traverse node dot left, and then right equals traverse node dot right, and this will need to return a number then, so it should be return 0. Okay, so now what am I going to do? I want to kind of like build that up. So as I get this, so I'm gonna get something back from here. So at 0, so once I hit the node, I'm gonna get 0, and then I want to take. I'm at this node, or I get 0, so I got 0 passed up. Now I want to then pass some value up to here. So I pass that my current length is 0 here. And then from here I'm able to check if we're the same, so 4 and 4. And then if we are the same, I can add 1 to here. Okay, and then this will also pass up 0. This right here will pass up 0, and I can tell that I'm the same. So that will be 2. But then what do I do here? Because I can't pass up 2. I would need to pass up, I can do like max of left and max of right, maybe. What I'm thinking, okay, so if node dot left dot val equals node dot val, then what do I do? Left plus equals 1. Similarly, I do the same thing for the right. So if node dot right is equal to the current node, then I change right to be plus 1. Okay, so then I need to return the max of left right. So that way I'm going to, for this one, it would be, this is going to return 1, and this is going to return 1. So they're both going to be, sorry, this is going to return 0. Then I'm going to check and say, okay, this is 4 and this is 4. Therefore, my right actually does have a 1. There's a 1 right here. So I'm going to change left to be 1. Here, I'm going to say, okay, my right, sorry, that's left. Right is also the same, so it is going to be a 1 here. So right now, left is 1, right is 1. And then I take that and I take the max, which is just 1, and I pass that up. Let's say that this was a 4 and this was a 4. So what's going to happen is this one is going to now check, like, okay, this one passed 1 up to me, but I see I am a 4 and it is a 4. So now I'm going to take my left side and add 1 to it. So now I have 2. So this length on my left side is 2, which matches up with reality, 1, 2. And then I'm going to look to my right. I'm going to go traverse right, come here, and then this is 5 here. So this comes to 0. This is 5, comes up here. This node checks like, okay, well, are we the same? This is a 4, this is a 5. No, it's not. So the return value for this node's right is going to be 0 because it doesn't pass up here. And then left is going to be what? 0 because it is null. Okay, so now this one is 4 and it returns up 0. Okay, and now this one looks, okay, well, I just got 2 from my left. Now I look to my right, I returned 0, but I checked, I'm a 4 and it is also a 4, so I add 1. So that means that I'm now looking at these two, and my current longest path needs to be updated to be the left side plus the right side. So I can go here, like if left plus right is larger than current length, then current length, current longest, okay, cool, equals left plus right. Okay, so I just constantly check, like, okay, can I combine these into a string that makes my path longer, my current path longer? And then I just pass up, but I don't pass up the entire length here. I have to pass up either my left side or my right side because the rules are in here. You can't go like this and then come up here. You have to come from here and then either choose a left or a right side to traverse down, because that's the longest path, like that. Okay, so return traverse node. Root. Val is not, type none. Wait, what? Why? Oh, okay, yeah, I'm checking the left. Okay, so I guess I can just do, like, if node dot left and this. Okay, so node dot right and node dot left. So I'm first checking if this node, this left child exists, and then if it does exist, then I am checking its value, because if the left node doesn't exist, I can't check a value of something that doesn't exist. And because here I'm only blocking if the current node exists, I'm not blocking if the left child doesn't exist or the right child doesn't exist. So fix that and see if we are on the right track. Wrong answer. Wonderful. That's great. Why? Um, does it pass like the test cases? Because this doesn't give me any information. I wish that it. What's this? Hey, okay, that's kind of what I was wanting. So my answer is 1, and it's expecting 2. Oh, right. Oh. I don't want to return. Okay, yeah. Hold on a second. Return current longest. So what I did here was I was returning the value from the node, like its return value. So it was returning up, okay, well, what is my left current longest? Well, I'm a 1 and this is a 4, so I can't add anything to my left. And I am a 1 and this is a 5, so it's nothing. So it's going to return nothing. So let's do current longest. But it's still wrong, so there we go. Okay, well, that's not helpful because it passes that one. So now it passes the cases that have the visualization, but not this one. But not all of the cases, which is highly not helpful. My output is 8 and it is expecting 6. Wait, hold on a second. This is not correct because I should only add them if both of them are the same, right? Else left equals 0, else right equals 0? Would that be correct? Okay, yeah, there we go. Okay, so either I want to check if my left child, if its value is equal to my current. So I'm up here, right? I want to check if my left value is equal to my current value, which is 1. And if it is, I want to add 1 to its current longest path. But if it is not, I don't want to take its current longest path and add, or I don't want to do its current longest path and then plus my right's current longest path, if both of them are not the same that I am, I want to say, okay, well, either you are part of me or you are not. Either you are with me or you are against me. So if you are with me, then I can add one to your current not longest path, but current connected path, along from node downwards. If you are against me, I don't want to consider your path. I don't care. You are zero. I'm not going to add anything. I can't add you to my path. So you're zero otherwise. And same thing with the right. And then you can add, because if neither your left or right are the same as you, then it's 0 plus 0, and that's not going to update current longest. If only one of them is longer, okay, well, then you do want to consider that. Like maybe the right hand side all of a sudden is longer than the current longest, but left is 0. So you just have to go with the right way. Okay, well, that's actually pretty cool. There we go. Okay, awesome. So this was a problem that I struggled with. I remember I was really having some difficulty trying to conceptualize this problem, understand this problem, and actually do it. Today, we were able to successfully solve this problem. So I'm gonna keep moving forward with these Leetcode problems, not not stopping. We're just gonna keep on pounding through them, and every time we come across a problem which unable to solve, okay, well, we're going to try to figure out how to solve it, forget it, like for about a week, and then try it again. So yeah, thank you guys so much for watching this video. If you like the video, please subscribe. That would be awesome. And I hope you guys have a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you later. All right, let's go.